If you've ever looked at a really big construction site, a skyscraper going up or maybe a complex bridge project, you get a sense that construction management is, well, it's fundamentally trying to manage chaos. You're juggling these three huge things all at once: the detailed planning, then all the permitting and approvals, and of course, managing the workforce itself, keeping those three synchronized. That's often where projects, they just fall apart, leads to massive delays, costs spiraling. It's tough. So today we're diving into a technology that's designed to fix that fragmentation: Ensemble AI systems. Our mission here is to understand how this integrated approach can maybe turn that chaos into something more like a well-oiled machine, treating the whole project as one thing. Okay, let's unpack this.
Yeah, it's a really crucial shift in thinking. Because, I mean, traditionally, software treats planning, compliance, people.
Hmm.
They're all in separate boxes, separate silos. What the research shows is that the real revolution comes when you integrate the data streams from all three. Your planning schedules, the regulatory stuff, the actual performance metrics of your crews, put it all into one brain, so to speak. When you unify those inputs, you stop just reacting. You actually start getting predictive foresight.
That sounds incredibly powerful, but let's get a bit technical. When we hear AI, often we picture, one big model doing one thing, like route optimization or something. What are Ensemble AI systems exactly?
Right.
And why are they like fundamentally better for an industry as complex, as messy as construction?
Right, that's a really important distinction. Ensemble AI isn't just one model. It's more like an intelligent system, an architecture, where you have multiple machine learning algorithms. Each one might be specialized for a different piece of the puzzle, and they all work together to make a more accurate decision. Think of it like less like having one single expert and more like having a whole consulting team, a diverse one. So you might have one model that's great at forecasting timelines, time series stuff, and maybe another that's specialized in understanding legal text, the regulatory documents, that's NLP, natural language processing. And these different models feed their outputs into, well, a kind of meta model. Sometimes it's called data fusion or stacking. This top layer weighs the inputs from the specialized models to give you a final prediction that's much more reliable.
Ah, okay. So the intelligence isn't just adding up, it's actually corrective. The group strength cancels out the weaknesses or maybe the biases of any single model. That seems super important for construction, where, like you said, the inputs, regulations, site reports, they can be unstructured, messy, very local.
Exactly right. The main benefit is stability. Reliability. Our sources suggest that by combining these strengths, these ensemble systems can generate predictions that are, well, significantly more reliable than your standard single model AI. We're seeing figures like maybe 15 to 20% reduction in schedule forecast errors on really complex projects, just because they can pull together all these different data types in near real time.
No, okay. 15, 20%. That kind of precision really does change the game. So let's dig into how this unified approach tackles those core issues. We mentioned the three pillars: planning, permitting, and people. Let's start with planning. That's the foundation, right? Setting the timeline.
Planning is definitely the engine room. Yeah. So the Ensemble AI starts by consuming just massive amounts of data, stuff a human project manager just couldn't process manually. We're talking historical data from hundreds of similar past projects, real-time info on material supply chains, hyperlocal weather forecasts, current resource availability. And this model isn't just spitting out a static schedule. It's constantly running simulations, millions maybe, every day.
Uh-huh.
It might predict, say, based on past projects, that this specific subcontractor team, combined with the high winds forecasted for Q3, well, there's an 85% chance of a 3-day delay on the steelwork phase.
Okay.
And critically, it doesn't just flag the risk. It proactively suggests optimized adjustments, like maybe resequence some interior work to minimize that wind exposure. It's about keeping the project on the most viable track, not just sticking rigidly to the original plan.
Okay, so if the AI can nail down planning with that kind of deep probabilistic analysis, that leads me right to the next major headache: regulatory risk. Permitting. I mean, even a perfectly optimized schedule can just crash and burn if a change means refiling paperwork, or if you accidentally push a phase past some critical environmental deadline. Permitting is, well, it's notorious. It's often the biggest bottleneck in the whole industry. Here's where it gets really interesting.
It really is. And the goal of the AI here isn't to replace the human permitting officials, let's be clear. It's about automating and managing all the process variables around permitting.
Okay.
This is where those NLP, the natural language processing parts, are so important. The system reads and digests all the relevant building codes, local, state, federal. Then it cross-references those codes against the project's actual technical specs. So let's take an example. Say the planning team wants to switch concrete types. Maybe use a rapid set mix to gain back 3 days on the schedule. The system instantly checks two things. First, it scans the local fire code, that's the permitting data, to make sure that specific mix is actually compliant. Second, it checks the people data. Are the crews certified to pour that specific mix available? Do they have the right training?
Oh, I see.
If the crew's booked, or maybe that mix needs a special environmental approval that takes 6 weeks, the AI flags that suggested plan change as high risk before the team even commits to it.
Wow. So it turns compliance from this, like, passive hurdle you just wait for into an active variable that interacts directly with the schedule in real time. It feels like the real power is stopping those cascading failures before they start.
Precisely. It's about forecasting the challenges. The system might analyze the permitting office's current backlog, look at its historical processing times for similar permits, and it might warn you, look, technically your permit application is due in 4 weeks, but based on history, similar ones took 7 weeks because of this specific complexity.
Oh.
That allows you to maybe submit some preliminary details earlier to kind of grease the wheels and shorten that cycle.
That makes sense. Okay, that brings us neatly to the third critical piece, the workforce. The people data. Because even with the best schedule and all the permits lined up, it all falls down if you don't have the right people with the right skills doing the right job at the right moment. How does using detailed people data, which, let's face it, can feel a bit sensitive, optimize the workforce effectively without, feeling intrusive?
Yeah, workforce management is absolutely crucial. And the system really focuses strictly on performance optimization efficiency metrics, not on like personal monitoring or anything like that. The data it uses includes things like aggregated skill sets across crews, specific certifications they hold, current shift availability, maybe metrics on past performance for specific tasks. Like the average time this particular crew takes to complete, say, a standard plumbing rough-in. The AI uses all this data to do really precise labor allocation. So when a task pops up on the optimized schedule, the model doesn't just grab any available crew. It actually predicts which available crew has the best combination of skills and historical speed to get that specific task done most efficiently. It ensures the right people hit the right tasks at the optimum time, minimizing downtime, boosting productivity.
Interesting. Can it also look ahead? Can it flag potential skill gaps? Like if the planning model predicts a big need for specialized welding 6 months from now, can the people data model warn you that you're currently only staffed for, say, 60% of that?
Oh, absolutely. That's a key secondary benefit. By constantly comparing those future needs from the planning side against the current and historical capabilities of your workforce, the system gives you these proactive insights. It might highlight upcoming training needs or signal that you need to start recruiting specific skills now. It helps you build and maintain a more stable, future-ready workforce, hopefully minimizing that expensive, last-minute scramble for subcontractors later on.
Okay, so this synthesis, this bringing it all together, that's where the real value emerges, right? You've gone from trying to optimize three separate things, planning, permitting people, to optimizing the entire project as this single cohesive, organism. So let's talk about that holistic payoff. What does it really mean when all three data streams are running together on one platform?
The holistic payoff is genuinely transformative. You're essentially giving the entire project operation a central nervous system. Integrating planning data, permitting requirements, and human performance metrics creates this single unified platform. And the immediate impacts are, massively improved communication, drastically fewer opportunities for human error slipping through the cracks, and, maybe most importantly, it dramatically accelerates the whole decision-making cycle.
Right.
Project managers get real-time transparency. They aren't waiting until the Friday status meeting to find out that, a delay in the inspection queue 3 weeks back, that's permitting data, has now pushed back the material ordering deadline, planning data, which means that specialized crew you booked, people data, is going to have 3 days of unexpected downtime next month. All those interconnected risks, they become visible almost instantly. This allows really informed decisions to be made in, minutes, maybe hours, instead of days or weeks.
That transparency must be the key difference. Because if I'm a project manager, I don't just want to know that I'm delayed. I need to know why, and crucially, what are my best options right now to get the schedule back on track?
Exactly. The AI doesn't just flag problems. It recommends the best course corrections. And it does that by weighing the impacts across cost, risk, and schedule simultaneously. It calculates those complex trade-offs. For instance, is it actually cheaper to authorize overtime for the existing crew, that's people data, or should we absorb a potential penalty for late material delivery, planning data, considering the current permitting windows,
Yeah.
permitting data.
Right.
Only a system that sees all three streams clearly can answer that kind of question reliably.
That level of integration sounds incredibly powerful, but it must also face some pretty significant hurdles beyond just the technical side. I mean, getting all these different data sources, especially across multiple contractors, maybe using older software, getting that all integrated cleanly must create real friction in practice.
Well, absolutely it does. And the sources we looked at really highlight two critical practical challenges, especially in construction, that need to be addressed for this to work. The first one is really about the standardization and the quality of the data you're feeding in. Construction sites generate just a huge variety of data formats, often managed by different subcontractors using different systems. Some might be legacy systems. Making all those inputs talk reliably to the central Ensemble platform. That takes really robust data governance rules and, frankly, quite a bit of upfront effort.
Okay, data quality and standardization. What's the second challenge?
The second is the need for specialized, pretty robust infrastructure. You obviously need serious processing power for these complex, multi-model AI computations. But you also need highly secure, resilient cloud storage solutions, especially given the sensitivity of some data. And maybe just as important, even with all that tech, the insights have to be presented through a platform that's actually user-friendly. If the site manager or the project manager finds it difficult to input data, or they can't easily understand the AI's recommendations, then the whole sophisticated system just becomes, well, an expensive paperweight.
Right. So adoption really hinges on overcoming that initial inertia, proving the ROI quickly, and making sure the tech backbone is secure, standardized, and usable. This isn't just like a software upgrade. It feels more like a fundamental shift in how construction projects get managed.
It truly is. Ensemble AI really does offer a path to a smarter, much more efficient future for construction. It provides those accurate real-time insights across basically every variable that determines if a project succeeds or fails, from the weather forecast next Tuesday down to the specific certification of the person welding that beam.
And as this technology becomes more widespread, becomes the standard way of operating, it must fundamentally change the job description for the people actually running these massive, complex projects.
It absolutely does, and that leads to a really interesting point. If integrating these three historically separate data streams, dense regulatory rules, hard concrete schedules, detailed human performance metrics, if that integration creates this level of holistic predictive insight, then the question for you, the listener, becomes, what new skill sets will the project manager of the future actually need? Especially when so many of these complex variables are being tracked, analyzed, and even proactively managed by a unified AI platform. Their focus is likely going to shift quite dramatically. Less tactical coordination, less checklist management, and much more towards strategic oversight, interpreting the AI's insights, making high-level judgment calls, and managing the really significant risks. It's a different role.